Hello guys, in today's video I will explain what is the difference between const pointer and a pointer to const and an easy hack to never confuse them again. If you don't know what are pointers, you can check my previous video for pointers basics, which I will link in the description below. Let's first start with what is a const variable. A const variable is a variable which, after declared, it cannot be modified. For example, let's have the following constant integer variable and assign some value to it. After we have declared this variable, we are not allowed to modify it ever again. Doing that will not compile. In order to create a pointer to num, we need to create a pointer to int const. We do it like that and assign the address of num. As you would expect, we are not allowed to modify the value of num through the pointer. So doing something like that is forbidden and it won't compile. However, in this case, we are allowed to reassign the pointer to another variable. Let's declare a second integer variable. And try to assign to the pointer the address of num2. As you can see, this is perfectly valid, and if we print the value pointed by p, it will print 5 to the console. We can also assign to that pointer a non-const integer. Let's create a non-const integer. Here we can reassign it to the address of num3. As you can see, this is allowed. However, since this is a pointer to const integer, we are still not allowed to modify the underlying value. So for example, if I try to assign a new value to it, that will fail to compile, as we saw before. What is a const pointer? A const pointer is a pointer which you assign an address to during the declaration, and you're not allowed to reassign the pointer to point to another memory address. We declare such pointer like this, and let's assign to it the address of num3. Now we can modify the underlying value of num3. We are allowed to assign new value. However, we are not allowed to reassign the pointer to point to another memory location. For example, let's create another non-const variable. We are not allowed to reassign the pointer to another memory location. This will fail to compile. We're trying to assign num3 or num4 because this is a pointer to non-const integer, so we are not allowed to assign the addresses of const integers. Trying to do that will fail to compile because, as we saw, through this pointer we are allowed to modify the underlying value. We are not allowed to reassign the address it points to. Now, if we combine what we learned until here, we can have a const pointer to const. As you might have guessed, we declare it like this. And let's assign, for example, the address of num4. Now, as I said, this is the combination between those two types of pointers. So here we are not allowed to modify the underlying value. So we cannot reassign new value to num4. This will fail to compile. And also, we are not allowed to reassign the pointer to point to another memory location. That will also fail to compile. Now I'll tell you a hack to easily understand those pointers and never confuse them again. The hack is to read the type from right to left. For example, if we go back to our previous pointer and start reading from right to left, we have a const pointer to int const. If we go back here, we have a const pointer to integer. As we said here, const pointer, we cannot reassign to it to point to a new address, but we can modify the integer. If we go back to the first pointer, we have a pointer to integer const. It gets really tricky when we have nested levels of pointers, so this hack is really useful. For example, let's have the following pointer. Now, as you can see, we have two asterisk symbols, so this will be some kind of a pointer to a pointer. Let's try to decipher the type by reading from right to left. We start from here. We have a pointer to const pointer to integer. We have such pointer here. This is a const pointer to integer. So in our new pointer, which I have to give it a new name, we can assign the address of CP. Let's read it again. We have a pointer to const pointer to integer. So we can modify the underlying integer variable, which was what CP points to. It points to num3. So by using the referencing operator or the indirection operator 2 times, we can access the underlying integer variable and modify it. Let's put a breakpoint here and run the program to show you the end result. As you can see, the value of P5 is the address of CP, which is the address of num3. Num3 equals 5. If we assign new value to it, it will become 123. Since P5 is not a const pointer, we don't have const after the last asterisk, we can assign another address to it. P5 equals, we don't have such pointer, but let's reassign to it CP again, just to see that this is allowed and it will compile. However, P5 is a pointer to const pointer. So we cannot reassign the value pointed by that pointer. What I mean is we cannot do this. We cannot. Doing that would mean reassigning the value of CP to num4, which we saw is not allowed. If we add const here at the end, that will become a const pointer to int. We are still allowed to modify the underlying integer variable. However, we are no longer allowed to reassign the address of P5. This will not compile. We can also put const at the beginning. And now this will become a const pointer to int const, which means that we are not allowed to modify the integer value, and this will stop to compile. One thing I forgot to say is that here in our first example, we can play around with the order of the const keyword. What I mean is that writing the last statement like this will give us the same result. I'll comment the first line. So this pointer is the same pointer as the following pointer. Here we can also use the hack, and reading from right to left, we have a pointer to const integer. Here it's a pointer to int const, which is the same. The same can be applied in our last example. We can rewrite this statement like this. I'll just copy it and put the const after the integer keyword. That's the same pointer as the pointer above. If we read it from right to left, we have a const pointer to const integer. That's it for today's video. I hope I brought you some clarity about const pointers to const. Just remember to read the type from right to left and you'll be fine and never confuse those again. If you found this helpful, don't forget to subscribe to stay updated.